So, good afternoon, everybody. What I would like to do today is to talk you through the way that the Icrp approach to protecting the environment, the framework that's being developed, has been put together, and hopefully demonstrate to you how it can be applied, how hopefully it is a pragmatic and simple system to use. We know there are some issues with it, which we'll hopefully touch upon, and I suspect there may be some questions at the end related to how it might be applied. But we want to go through, first of all, thinking about how we use this approach. And I think when you're thinking about the protection of the environment, there are a series of questions you need to ask yourself related to the situation that you find yourself in. So whether that's a planned, an emergency, or an existing situation. And the types of questions that you might want to consider asking are along the lines of, what is it we're trying to protect? What are we trying to demonstrate the protection of? We have to remember that in the real situations, what we're actually trying to do is protect wildlife, in this instance, real biota. We're interested in protecting wildlife more than domestic animals and so on. So we need to think about the complexity of life, etc., that we have to address. And we have to think about the protection goals that we have in this place. So some of the things that we need to think about are related to what are we trying to protect? Now that may well be different under different exposure situations. So with planned situations, you may have a very different objective in terms of protection. It may be about protecting a local habitat that's considered to be perhaps of conservation value, as opposed to an existing situation where you may have a situation where you've already got contamination present, and you may be needing to think about the types of decisions that you're going to make, perhaps not so much related directly to the radiation effects on the wildlife, but how you can incorporate the radiation effects on the wildlife into the decision-making process about what you're going to do with that exposure situation that you're in. We always want to try and do more good than harm with the environment, okay? So then we have to think about what kind of animals and plants are we actually interested in, what kind of biological effects are relevant to the type of work that we're talking about, and what kind of dose are we getting. So we need to link together the dose and the effect relationship so we can understand something about the likely consequences and risks to the wildlife. And I want to try and talk through how we can use the different the reference animals and plants that have been proposed by Icrp and incorporated into the framework, how we can use those to address some of these issues. We need to have a look, first of all, at the types of protection goals that we're thinking about. In many cases, this is reflecting international guidance and approaches in terms of protection of biodiversity and so on, and conservation of species. There are obvious benefits to conserving species as well, because in certain circumstances, of course, the species may well actually be foodstuffs and so on, and natural resources for us as humans. So we need to incorporate protection to make sure that we have a sustainable environment that we're trying to use as well. And we need to recognize that radiation is just one of the stresses that actually is imposed upon that environment. And we need to put this into context with what happens with chemical risk assessment and so on as well. So all of the information I'm going to be talking about today has been put together in the context of what happens elsewhere in chemical risk assessment and so on as well. So we've got our protection goal as specified within Icrp publication 103, that we want to try and protect biological diversity and conserve species and so on, and habitats. We also then need to think about what species we're actually interested in, and this is where it gets very complicated in terms of looking at microorganisms all the way through to large multicellular organisms, so in the example here, the killer whale, etc. So the issue here is, how do we address this complexity in a simple and pragmatic manner that will allow us to have some way of coming up with a decision as to whether we can demonstrate whether the environment is protected, or whether we need to be concerned, and whether we need to take into account the potential impacts of radiation on the wildlife that we're trying to protect. So what we can do is think also about the types of effects that are going to be relevant in this circumstance. Now, obviously, with this, we're not really interested necessarily in protecting individual animals. So what we're thinking here of are the types of effects that may be relevant in terms of reproductive capacity or reproductive success for the animals. So things like early mortality, where we have a life shortening and therefore a reduced reproductive capacity, may well be important in terms of the organisms that we're interested in. We might also be interested in certain types of morbidity, whether the animals are growing quickly enough, whether they're able to maintain their fitness within that environment. So certain types of endpoints may also be relevant in terms of morbidity. And obviously we can have direct impacts on reproduction through, for example, changes in fertility and fecundity in terms of birth rates, in terms of the number of offspring, etc., that come through this process. We have on the bottom here the induction of chromosome damage, and I have to confess here that this is one that has to be relevant to population levels. So it's sometimes difficult to see how mutations won't be manifested in the other effects that I've already mentioned. And this is one of the things that we need to be careful with. Sometimes the markers of aberration for chromosome aberrations and so on could be useful as markers as to what might happen, but I think we need to make sure that anything that we're using in this category is actually relevant to what we see at an individual level. But these types of effects then need to be collated for a number of different species or a number of different wildlife types if we're going to actually think about how we can apply some form of numeric criteria to actually decide whether we're likely to have a problem in the environment once we've got through this assessment process. The other aspects, as you heard Kathy talk about on Tuesday, are things to do with demonstrating what the dose is to the organisms, what we're actually interested in knowing about the dose rates and so on. And for now, we're using simplifications again in terms of the ellipsoid shapes and so on that we're using to actually make it easy for us to actually do the assessments in terms of dose rates. And Kathy will talk later on about how we might be able to move forward with this kind of approach in terms of using voxel phantoms and so on to give us better understanding of the doses to particular organs that may be relevant to the biological effects that I've just mentioned. But again, we need to know for these particular types of organisms that we're interested in, we need to know what the relationship between the activity concentrations in different organs may be to be able to relate that to the actual activity, the dose rates and so on, and the effects that we see. So we have to understand the different components in this approach. And once we've got all of this information together, we then have to put this framework together for us actually to apply the system. So how do we actually do this in a pragmatic way? Well, you'll have come across this slide already. Kathy presented it on Tuesday. And what we're thinking here in terms of the approach is that we want to use these reference animals and plants. And they're analogous to the way you might consider a reference person to be put together. One of the beauties of using this type of approach is that if we get new scientific data, we can actually make amendments into the framework and we can actually understand what the consequences of those changes in terms of new scientific information is and how it's going to relate to the exposure situation that we have, the activity concentrations that we either measure or model in the environment, and how they can then be reflected through the reference animals and plants for the wildlife in terms of the doses that we're going to see. And how do those doses then relate to the effects? Well, that's what we can do through the derivation of the derived consideration reference levels, which I will talk about in a moment or two. The actual whole process is there to help us make decisions. This is what the whole framework is about. It's making decisions from a radiological protection point of view on what we're going to do in terms of wildlife protection, environmental protection. What are the types of organisms? I know there's been lots and lots and lots of debate about the particular 12 reference animals and plants that have been selected. There is nothing sacrosanct about this list. That's the first thing I would say. But they've been selected on the basis that they are typical of environments, and by typical I mean that they are organism types that you may encounter in the environment or ecosystem that you're interested in. That is not true in every case, but it is a way for us to construct the information together into databases that we can use. So we have a range of different organism types. We actually have 2 mammals, which from a personal perspective I think was very strange, because the only real difference I can see is in relation to the dosimetry. But they're there, and we need to be able to use them to actually go through this process in terms of thinking about how they relate the dose and the effects that we're interested in, and how can we then use them in terms of understanding what the risks may be to the wildlife. So we have mammals, we have birds, we have different types of fish, we have insects, we have plants and so on in this list, okay? One other thing just to point out before I move on from here, they're actually set at the level of family. So often when people say that your particular species isn't actually considered, sometimes it may actually be considered in terms of the family level that the RAPs are set at. And I'll come back towards the end of the talk to think about how we can actually make use of this where we are actually looking at species that aren't included or aren't relevant to this particular list. So I'll look at that later on. Just wanted to point this out though, what we're talking about here are points of reference. This is points of reference for us to actually think about how you can move through the system of radiological protection. And if you think about a map, and I say to you, I want you to go to address X, what you have to do is sometimes explain where address X is actually located. And in those circumstances, it's maybe useful to be able to say, well, there's a cinema here, and there's a hospital here, or a university here. They are points of reference which allow us to move through the city to actually find where we're actually trying to go. And in a way, that's what we're trying to do with the reference animals and plants. And by constructing the databases in the way that we have, we've been able to collate information on the effects. And these organisms have also been selected on the basis that we can actually do studies on some of these organisms. Although I have to say, I'm not sure who's going to do the deer. That could be quite interesting. But we can actually do studies and biological effect studies and so on these organisms. We can build new information and we can build new inputs into the effects studies, for example. And what you can do by collating all of that is pull them together towards these derived consideration reference levels that I mentioned previously. And the key word in this title is the word consideration. What we're talking about here are bands of dose rates where there may be some probability of biological effect occurring. And this is based on the information in the biological effects in the literature. In some cases, we have gaps in our knowledge, and so sometimes the DCRLs have been set to be precautionary. So sometimes they're in a band which is perhaps lower than where we actually have definite information about the presence of effects. But these bands mean that we can then start to think about, having constructed this reference set and these reference information, we can now think about how we can apply this in terms of the biological effects and how we can use this from a regulatory type point of view and how we can use it in terms of the radiation protection point of view. How do you actually apply these DCRLs in practice? Well, just to give you a little bit more information, these are just a couple of examples. This is for the reference deer and the reference flatfish, to give you a couple of differences. And you'll see in the tables, you'll see different types of words. And in some of these words, you'll see that there's a low probability of effect, a very low probability of effect. And in some of the table places, you'll see that there are effects that are observed in the information that we have. And it seems logical for a planned exposure situation where we're deliberately going to put a source into the environment that we would want to avoid any potential impacts in the environment. So in those circumstances, you would want to use the bottom of the band as the sort of target and maybe not want to go into the band in its own right. So in these circumstances, for situations where we are going to deliberately introduce sources into the environment, it seems to make sense to me that the target point that we would be using is the bottom of the DCRL band. Now, I know that if you look at the actual DCRL bands, some of the DCRL bands are very low in terms of their dose rates. And that's something I think that we need to look at as more information becomes available to us, whether we can refine these dose rates a little bit better. But the bottom of the band would be the place where you would want to avoid going into the place where you would consider what was happening in terms of the effects. It does not mean it is a limit. It is quite clear that ICRP does not wish this to be a limit, okay? And that is quite right. We have no way, if you're using limits, we have no way of applying equity within wildlife and humans and so on. So it makes sense not to be a limit. But what it is it's a point where you would try to avoid going into. So in these circumstances, for a planned exposure situation, for all sources, you would try to be below the band in terms of the areas that we were interested in. If you think about an existing situation where we have known contamination present in the environment, here we have a situation where we have information about the concentrations in the environment, we can calculate the doses and so on. And there the idea would be that you would be trying to reduce the potential impacts in the environment by moving towards the band. So you would want to be aiming, the idea would be to be moving into and perhaps even below the DCRL band that we've got. But obviously that's got to take into account any potential consequences to humans who are actually going in and cleaning up the sites and so on. So this is part of the decision-making process. It gives you information about how you can move from a situation where you've got contamination in the environment to somewhere where you can start cleaning it up, or whatever you do to it in terms of walking away from it, you will have some information about the likely consequences to the organisms that we're interested in. And when it comes to emergency situations, in emergency situations, we can often predict or we can measure the dose rates that we're seeing in the environment. And again, what we can do here is actually start to think about what the different bands mean in terms of the higher bands well above the DCRLs, the actual bands where we're considering what might happen. In these circumstances, you're looking at the types of effects you might typically see in the environment. Why would we want to do that? It's incredibly unlikely that we're going to try and do anything in the acute phase of an accident in terms of what's going on to the environment, etc., in terms of trying to clean it up. But what we should be doing is communicating what's likely to be going on and giving people information about the likely impacts that are going to be happening to the wildlife. And that will change over time. And using the DCRL bands, it is possible to start to think about how you can communicate through the different time phases of an incident that's happened. So in an emergency situation, we're not saying that you would rush in to do something for the environment, but it would give you the communication tools that you could then use to actually go and have a look and see what's going on. And putting all of these things together, we can actually start to think about how we can actually apply this in real assessments and so on, and real situations where we're trying to make a decision about what's happening in the environment. And here the system is that we have the reference animal and plants, and we have the derived consideration reference levels for types of animals. And what we need to be thinking about is, what can we actually do to interface with our organisms, our reference animals and plants? How can we interface those with the organisms that we are actually trying to see in the environment that we have? So we might have particular bird species, we might have particular mammal species and so on that we need to do assessments for. And in those circumstances, what you're doing is you're trying to use something which we've termed a representative organism to be able to do your assessment. And what you can do from the system is actually calculate the radionuclide intake and external exposure to some of these organisms, and you can then compare the findings to the DCRLs and try to see how they compare. But to do that, we need to make the link between the different types of representative organisms and the reference animals and plants. So representative animals and plants are there to actually give you your assessment endpoint. And we need to think about the biology, the approaches that we have in terms of dosimetry, and the actual information that we have in terms of the effects and so on, to actually enable us to actually link those representative organisms, the things that you're really interested in for your habitat that you're trying to make the assessment for, to what we have for the effects of the information, those reference points that we have within the derived consideration reference levels. And it's that linkage which should allow us to develop pragmatic approaches in terms of the systems, and maybe even start to think about how we can go forward, where you can actually make some simple statements about the types of concentrations that perhaps you would like to see in the environment, below which you would be confident that there would be no impacts on either, in this case, the representative persons or the representative organisms. So this is somewhere we're thinking about trying to go within the Committee 5 in terms of the future processes. So I hope that's given you a little bit of a flavour for how the assessments would work and how these reference animals and plants would go forward. I'd just like to say that this was based on the work of Task Group 82, and these are the people involved in Task Group 82 in terms of the new publication 124, which is in press at the moment, which describes this in more detail. Thank you very much for your attention.